Hi, I'm Balaji Chippada and welcome back to my YouTube channel. In continuation of our Python series for data science, in this video, let's learn about pandas by using a dataset. In the previous video, we have learned about how you can create a data frame out of multiple data structures that we have learned before, and we have done basic data manipulation as well. But in this video, we will see how you can load a dataset and how you can do manipulations on top of it and how you can access the different types of data inside your data set, and we can also see how you can drop the columns as well. So without any delay, let's get started with the coding part. So as usual, let's import pandas as pd as the first step and let's execute this. Okay, and before going into the code part, I will explain the dataset that we have at hand first. So I have this dataset called iris.csv. It has 6 columns, and the first column is id, and second we have sepal length, and third we have sepal width, petal length and petal width, and at the end we have a column called species, and all of these numbers are of float values, and in the column species we have the flower names. So if this data is basically a flower data set, and what it specifies is if a flower contains sepal width of 5.1, sepal width of 3.5, petal length of 1.4 and petal width of zero point 0.2, this flower is basically classified as iris setosa. So if you google iris dataset like this, you get three different flowers, which is iris versicolor, iris setosa and iris virginica. And you can see this is what we call it as a sepal inside a flower, and this is what we call it as a petal as well. And for each of this sepal we have length and width, right? So let me show you that. So this is a sepal, and this is the length of the sepal, and this is the width of the petal sepal, sorry, and this is the length of the petal and this is the width of the petal. So looking at the sepal and petal width in centimeters, we can classify whether the flower belongs to either versicolor or setosa or virginica. So this is what this data set is. Now let's read the data set inside your pandas data frame and see what are all options that we can do. So I have this pd.read underscore, and if I press control space, I get multiple options here. So as I mentioned in the previous video, pandas offers very high flexibility in reading a lot of different type of data sets. When I say pandas.read underscore, I can read clipboard, CSV, Excel files, feather files, GBG, HDF, HTML, JSON, Parquet, Pickle. So these are all the different type of formats that pandas supports actually, which is really good, right? And really extensive as well. But in this video, because our dataset is CSV file, we will understand how you can read CSV files and then do manipulations on top of it. And going forward in the next later videos, we will also understand how you can read multiple datasets as well, like Excel, PDF, JSON and all of those things. But for now, let's stick to this. Now I'm saying is df equal to pd.read CSV file. I'm giving the file name here, iris.csv. Before proceeding further, I would want you to go through this documentation page for pandas read underscore CSV, and this is a method. It takes these many different types of keyword arguments, guys, and I'm not going to cover all of these keyword arguments, but as we proceed through the course, we will learn everything when the need comes. Okay, now we are just using the file path and we are giving the file name, and we can use separator, delimiter, index columns, headers, names. There are a lot of arguments that this pandas read.csv takes, and we are not going to cover everything. If you want, you can go through and read through all of these things, what are these arguments are and what options it will take, and you have the code examples in the below as well. If you go a little bit down, you have the code example like this, and you can read through the documentation. But for now, let's read this pandas.read CSV using the iris.csv file and execute this. My CSV file got loaded into a data frame like this, and I got my data. It has ID, sepal length, sepal width, petal width, and species. As we learned in the previous class, we have the index column as well. And if you see, ID is not an index column. It might look like the same, but it is a column inside your dataset. And this right here is the index column. So this is your index column, and ID is basically acting as an index as well, but it is not a default index column. It is a column inside your dataset. And we have sepal length, sepal width, length, petal width, and we have species. We have setosa, virginica, and versicolor as well, and we have the values here. And this is your data set. And if you see here, we have 150 rows and 6 columns. So this is the shape of your data set, and the 6 columns are basically id, sepal length, sepal width, petal width, and species. Index is not going to considered as a column inside your data frame. Hopefully that is clear. Now we have loaded that inside a pandas data frame. Now let's see the type of this data frame. So it returns pandas core.dataframe, and we know it. Now let's extract the index column. We can get the index column as well, right? See here, it is saying that range start 0, stop 150, and a step of 1. If you look at here, we have the index as 0, 1, 2, 3, and every record there is a step increase of 1 value, right? And we have up until 149. That means it is starting from 0, ending at 150. This is exclusive, and then we have a step of 1, and it is of range function. So this index is basically range index of 0 to 150 and a step of 1. So that is what it is returning in the below. See, hopefully that is clear. And I would want to access the columns, then I would do df.columns. I will get id, sepal length, sepal width, petal width, and species. Here I got the columns. Now what if I want to get how many columns are present? There are two ways that you can do. Either you can print df.shape. df.shape returns both rows and columns, and you can get to see that number 6 is the number of columns that we have in our data set. Or else you can just do length of df.columns. If you see, this is inside a list, right? And inside a list we can access the length function as well, and if I execute this, I get the value as 6. And I can convert this specifically into list as well. It is not that much needed, but you can do like this. So if you do like this, what happens is, instead of creating it as an index of the list, it will directly return you the list. And once it is converted into like this, I can do a for loop as well. For I in df.columns, print I, and I can iterate through my columns one by one. Hopefully that is clear. If you have any queries so far in this session, please let me know, and I will clear each and every one's queries. And we have another function called df.access. What it will return is, it will return you the information of the index and the columns. If you see, I have range index 0 and 150 and step of 1. This is your index, right? And then we have all the columns. So it's df.access is basically a sum of df.index comma df.columns. If I execute this, see, range index start from 0 and this one. So instead of printing out two different parameters or functions, we can just do df.access, and it will return you the corresponding output. Hopefully that is clear. And I can access like this as well, I guess. Let me execute this. See, and I can access like this. And why am I able to access like this? Now let's execute this like this. And if you see, it is enclosed inside a list. Okay, so this is a list, and inside this is my first element up until this, and we have a comma, and we have the second element, right? And then when I do like this, I am saying access my first element inside my list, and that is how I'm able to access using a df.access. And now, as we learned again, we have df.shape and df.index and all that stuff. If you see df.shape, it is a tuple of data structure, right? And if it is a tuple, I can access the first element and second element differently as well. If I do like this, let's execute separately. And if I execute this df.shape of 0, I can get to see how many rows that I have, and I can say df.shape of 1, and I will get number of columns that we have individually. Hopefully that is clear. Now the next important stuff is, here we have 150 rows and 6 columns, and we cannot look at all the data set at a single time, right? And if you want to look at a multiple records at a single time, that is where we have this function called df.head. So what it will do is, it will print the top 5 records of your data set. If you see here, 1, 5.1, 3.5, 1.4, up until the first 5 records, by default it will print. And if you see, these are the first 5 records that we are printing using a df.head. And head also takes one more parameter called n. So if I say df.head of 10, that means it is going to print me the first 10 records of my dataset. Instead of 5, I can specify how many records that I want to print. It could be 5, 8, 10, 15, 20, even 100 as well. If I do 100 like this, it will print 100 records, but if you see, it is saying blah 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 in between because it is not able to print. And we can override this as well by using some commands in Jupyter Notebook, but I will teach you that in the later parts, but not right now. So let's stick with df.head of 10, and we get the 10. Now these are the records which are the top of your CSV file. Now what if I want to get me the records at the bottom CSV file, because the distribution might varies, right? Top records might be something like this. If you see, all of these records are of Setosa, but what if I want to get me the last 5 records? That is where df.tail function will help you. And if I execute this, I get the last 5 records of my dataset. And if I can just do df of tail of 20 or 10, it is same like head, but it is going to return me the last records. If you see the index here, it is 140 to 149, and I have only 150 records in my dataset. That means these are all the last 10 records in my dataset. And this is an important function called df.sample. Let's execute this and see what it is going to return. If you see or notice the index values, it is of 102, 0, 33, 131, 116, 64, 48. So these are not of sequential manner, right? And all of are from different rows. So what sample will do is, it is going to return you 10 samples in random order of your data set, right? It is not going to be in a sequential manner. If you want to see how the data set looks like at random positions, then you can see here. If I do df.tail, I can only get Virginica as a species, right? And if I do df.head, I can only see Setosa as the species. But are there any other species that I am not aware of by looking at this dataset? That is where df.sample comes into picture. When I use df.sample, I can see that Virginica, Setosa, versicolor, all of the 3 different types of flowers are included in this dataset. So this is why sample is needed, and we will understand about sample and population in the statistics chapter in detail, but you have to understand why this is useful. We have another function called df.info, and if I execute this, I get the information of the data set completely. This is like information. Okay, here I can see this, it is of class data frame. Okay, df is of class data frame, and then we have the range index 150 entries. That means we have total 150 records, and we have the columns total 6, and each of the column is named like this: id, sepal length, sepal width, petal length, petal width, and species. And we have 150 non-null records. In the previous video, we have learned about null values, right? np.nan. It will also give you how many null records are present inside your dataset. Right now my dataset doesn't contain any null values at all, because all of the values are not null. And we have the data type as integer, and all the other 4 columns which is of float values as a float 64, and then we have species which is of string data type which is of object here. And hopefully that is clear. And we have the memory usage as well. One more important function that we have is, if you see here, I have 4 columns, and I want to find the mean or average of sepal length over the data set. How can I do it? I cannot just do for loop and calculate all of that stuff, right? That is where df.describe comes into picture. And if I execute this, what I'm saying is, I'm saying describe my data set. Okay, so what describe will do is, describe will take all the numerical data or columns. So it could be id or float values as well, but not string types. Okay, so if you see here, when I do df.describe, I get the columns id, sepal length, sepal width, petal length, and petal width, but not species, because species is not of integer or float data type, it is of string data type. And what it will do is, it will return you multiple statistics here. So if I have to explain this, it will show you the count, it will show you the mean, standard deviation, minimum, 25, 50, 75, and max. So from looking at this, I can say that sepal length, I have 150 records in total, and the mean of sepal length is 5.83, and the mean of sepal width is 3.04, and mean of petal length is 3.75, and petal width is 1.99. And we have standard deviation, minimum value is 4.3, and if you see, minimum value is 2, and minimum value is 1, and minimum value is 1. And maximum we have 7.9, 4.4, 6.9, and 2.5. If you see, by looking at this, I will get a high level statistics of what the data looks like. Okay, and we will understand all of this standard deviation, 25th percentile, 50th percentile, 70th percentile in detail in the later videos. But let's understand that around 25 percentile of the sepal length is around 5.1. So we will understand that later, but by looking at df.describe, I can get a high level stats of how the data looks like. Now, so far we have learned that we can access the dataset using df.sample or df.head or df.tail, but it will give you some sequential data at the top records or the bottom records or some random records. What if I want to specifically access these 5 records? How can I do it? That is where slicing comes into picture. Okay, just like list, we have the slicing as well. Now let me print a df here, and this is my df, and let's do df.head rather than df, and let me zoom out a little bit so that it is easy for you to understand. And I will do df of square brackets 2 is to 5. Okay, I will explain this in a bit. Now let's take this. Yeah, so this is my df of head. These are my top 5 records, and I'm doing df of 2 of 5. I'm saying start from second row, okay, index 2, and up until 5, but not 5. That means get until 4. So I get the records 2, 3, 4. So this is the set of records that I was able to access by using df slicing. Just like list, we can do the slicing as well. Hopefully that is clear. And now we have df0 of 1. I'm saying start from 0 index and end at the first index. So I'm going to return only one record, which is of first record. Okay, and I can even access 20 to 30 as well. So like this, I can access multiple records at different positions using df.slicing. And I can do something like this, and I will do 2, and if I execute this, so what this mean is start from 20 and at 30 with a step size of 2. So that means I get 20, 22, 24, 26, and 28. The difference between each of these records index is 2, right? That is what it means. Here I'm accessing the whole data using this df slicing. What if I want to access or see only the 2 to 3 different columns that I want? I don't want all the columns to look at. So that is where you can just say df of, and inside this you need to specify a list, and inside that list you need to give whatever the columns that you want to see. So if I do like this, I will only print sepal length and sepal width because these are the only 2 columns that I have provided here. And then we can mix and match this column selection and the index selection here. So I will say df of this one, and I'm saying return 0 is to 4, and if I execute it, I will get in the first 4 records of these 2 columns. So why is this possible? If you look at the type of this one, okay, this is again a data frame. See, this is a data frame. If you see here, this is a df is a data frame, and we were able to access like this. And here, instead of df, we are having this whole step. So I can do something like this. So df1 equal to like this, and I can just do df1 of this. Sorry, df1 is not defined right now. I can execute this and I can execute this. See, both are same. I'm just directly doing this so that it is easy for you to understand as well. If you want, you can follow whatever the notation is easy for you. And I can do something like this. I can first select the records that I want, and I can then select whatever the columns that I want. Here I'm selecting the columns that I want and then selecting the records that I want. It could be of any way and it will work. And this is just like using the step size as well. Hopefully you understand that. Now we have seen how to access the columns, how to access the records, and how you can do all of these manipulations. Now the next important stuff is how to delete the columns. Okay, now let's read the data set again. And here this is my data set, and then what I'm saying is I want to delete the column called sepal width, let's say. So for that, I have a function called df.drop, and inside this I have columns as a keyword parameter, and I'm saying passing as a list of values, which is sepal width centimeter. You have to make sure you are providing the exact name. What if I do M capital? Okay, this is not a column name, right? Because it is not matching with this name. And if I execute this, it is going to throw me an error called key error. because sepal width centimeter is not found in the axis. So I would have to give the exact same name. And if I execute this, now I got a data set in which sepal width is not present. And because you are just deleting the data set inside your pandas data frame, your original data set is still going to have all the columns. Here we have dropped a column, right? Is there a way that you can drop the rows as well? Yes, that is where df.drop by using the indexes. If you see, this is the 0th index record and this is the second index record. What I'm saying is df.drop list of 0 comma 2, because here I'm not specifying the columns as a keyword parameter. It is going to drop the record 0 and 2. And if you see the index starting from 1 and there is no index for the value 2. Hopefully that is clear. And one more thing that we have is in place equal to true. If you notice here, I am dropping the data frame and then I am saving it inside df.dropped rows. Now what if I will print df again? Now if you see, I have all the records as it is, right? Because whenever I'm dropping the dead table, I'm saving it inside another parameter called df.dropped rows, but I'm not completely dropping the records in my original data frame. So if I want to drop it from my original data frame, that is where in place equal to true keyword parameter comes into picture. What I'm saying is drop the column sepal width and save the dataset inside your df itself. And if I execute this, I have my df in which there is no column called sepal width centimeter. Hopefully that is clear. If you have any queries so far, please let me know in the comment section below. And then I can do df.drop02 and in place equal to true as well, just for dropping rows. And then we can do like this as well. We can drop both of these things. So let's say I'm dropping the index equal to 5, which is my row number 5, and then I'm dropping the columns petal length centimeter. I'm saying in place equal to true, and let's execute this. So what this will do is it will remove the row number 5 from your data set, and it will also remove the petal length column from your data set when you do like this. Hopefully that is clear. And that's all for this video, guys. We have learned how to load a dataset, how we can do manipulations, what is shape, how you can access different rows, records, columns, and how you can drop the datasets as well, and a lot of basic functionalities on DataFrame. And in the next video, we will learn something which is very important called lock and iLock functions, where you can access any record, any column at any position, guys. That is very powerful tool and function. I will explain that in detail. And if you are liking what you are watching, please do subscribe and click that bell icon to get notified daily. And we will meet in the next video. Bye bye.